So what is sharding in terms of blockchain? The blockchain network is the database with the nodes representing individual data servers. If we apply sharding to blockchain, this would mean breaking up the blockchain network into individual segments or shards. Each shard would hold a unique set of smart contracts and account balances. Nodes would then be assigned to individual shards to verify transactions and operations instead of it being responsible for verifying every transaction on the entire network. So how does sharding work anyway? To explain sharding, let us use the Ethereum blockchain as an example. The Ethereum blockchain currently has thousands of computers, 8,622 to be precise, each lending a certain amount of hash power to the network. It is this hash power that allows the Ethereum virtual machine to execute smart contracts and run decentralized applications. A transaction passing through verification process can take a long time. Currently, Ethereum is operating around 10 transactions per second. Visa, by comparison, does 24,000 transactions per second on average. Adding computers to the network will not necessarily improve efficiency. As the whole ledger is kept on every single computer on the chain, the verification will just become longer. With sharding, blockchain will be divided into separate shards. Nodes will only have to run the part of the ledger they are assigned in order to execute processes and validate transactions instead of maintaining the whole ledger all of the time. As mentioned earlier, one of the biggest problems facing blockchain network is the issue of scalability. The more popular blockchain the network becomes, the more users are initiating transactions, decentralized applications, and other processes on the network. Increased transaction activity places increased demand on nodes to verify transactions, and there is a real threat that these blockchains could become clogged up. If this happens, transaction speed becomes painfully slow, which is not an ideal situation for long-term sustainable blockchain and operations. So if the blockchain is broken up into smaller segments with teams of nodes assigned responsibility to individual segments, every node won't have to maintain the entire ledger to execute every operation. Transaction validation can therefore happen in parallel rather than in a linear fashion, increasing the speed of the entire network. It provides a solution to the scalability issues surrounding the blockchain networks and therefore makes it more sustainable in the long term. But the main challenges of sharding relate to communication and security. If you split the blockchain into isolated segments, each shard will appear as a separate blockchain network. Users and applications of one subdomain will not be able to communicate with users and applications of another subdomain without the implementation of a special inter-shard communication mechanism. This adds to an additional layer of complication for developers to think about. Security also becomes a concern as it is easier for hackers to take over a single shard due to the reduced hash power required to control individual segments. Also known as a single shard takeover attack or a 51% attack, once a segment has been hacked, the attackers can potentially submit invalid transactions to the main network. Or it is possible for information in this specific segment to be invalidated and lost permanently. Two additional proposals have been suggested by developers to improve performance and transaction speed on blockchains. This first is to increase the block size with the basic thinking that the bigger the block size, the more transactions can fit into a block and therefore the higher the number of transactions per second. Although this is true, it also means that the bigger the block size, the more computing power is needed to verify the block. If block sizes were to be increased indefinitely, only the most specialized, highly powered computing equipment would be able to handle the required processing power needed to act as a node. The increased cost of this type of equipment would mean node pools would necessarily become smaller and more centralized, increasing the risk of a 51% attack. Increasing the block size will also require a hard fork, which risks splitting the community. If not everyone upgrades to the new blockchain, two separate chains will exist using two separate coins. Because of these issues, increasing the block size is only a short-term solution. The second proposal is to use altcoin, so the different functions and the different applications will run on their own chain with their own coin. This would increase performance because you don't overload a single blockchain, but it will also increase security risks because all the hashing power is now split over several blockchains. Again, this makes it much easier to hack the network, as the amount of hashing power needed to execute a successful 51% attack is much smaller. Therefore, it is not a good solution.